Land use changes, increase of air temperature, higher rainfall intensities and shifts in their seasonal occurrence lead to a more often occurrence of extreme events such as flash floods and droughts. These changes have a profound effect on the availability of water resources. This is the reason why it's necessary to focus both on their early forecasting and adaptation measures, which will help to mitigate their consequences. The hydrology research team at the Institute of Hydrodynamics is primarily focused on the soil-water regime description in the mountainous regions of the Czech Republic. Why have we chosen the mountainous regions? Because the higher amount of precipitation altogether with mountain forests significantly affect the runoff formation. The primary research site is the Liz experimental catchment, located in the sub-montane part of the Bohemian forest. The watershed is involved into the European network of small representative catchments. The entire area is covered by the spruce forest with scattered beech stands. The total water balance, soil-water regime, and the vegetation water demands are the main tasks of our research. A professional meteorological station, which is located close to the catchment, serves for the monitoring of energy and matter fluxes governing the behavior of the ecosystem. They comprise precipitation, air temperature, wind speed, radiation balance, and other hydrometeorological and hydrophysical parameters. Surface runoff is observed at the closure profile of the entire catchment. Besides the amount of runoff, the elementary hydrochemical characteristics of the stream water, precipitation, and throughfall on the forest floor are measured on the long-term basis. Apart from the main meteorological station, two additional ones are located inside of the catchment. One in spruce and second in beech forest canopy. Both are equipped with sensors monitoring the soil-water regime and hydrochemical characteristics of the soil water. From the long-term perspective, the attention is paid on the underrepresented hydrological processes, whose significance is increasing in the context of the climate change. Therefore, the activities of the group concern the subsurface water flow, evapotranspiration, and amount of deposited precipitation, especially fog water. Unique data originating from the experimental sites are used as a basis for the modeling of the water fluxes within the landscape. This enables to estimate future changes in the availability of water resources and to assess the effect of designed adaptation measures, namely land use change, influence of small reservoirs, or alternation of soil properties. Besides the Liz experimental catchment, the research activity is also expanded to the upper parts of the Bohemian Forest, Giant Mountains, and Jezera Mountains. These regions serve for the investigation of the climate change impacts on ecosystems with the focus on the water regime, bark beetle outbreaks, and other extraordinary events. The main goal of our work is to extend the knowledge necessary to ensure sufficient amount of available water resources for the human society. And this is not an easy task indeed.